Welcome to the DIY Honda Garage channel. The DTC P0103 indicates a high voltage condition within the mass airflow MAF sensor circuit in Honda Accord vehicles produced between 2012 and 2017. The MAF sensor plays a crucial role in measuring the density of incoming air and is vital for the powertrain control module, PCM, to adjust fuel delivery and ignition timing for optimal engine performance. This sensor is a hot wire airflow meter located in the intake air passage, designed to cool by the incoming air, and maintains a constant temperature using electrical current. If the PCM detects a MAF reading above the specified upper limit of 4.89 volts for a sustained period, it flags this fault by turning on the malfunction indicator light, MIL, and stores the P0103 code for further diagnostics. Understanding this error is crucial for restoring the vehicle's performance and ensuring emissions compliance. To conclude, the DTC P0103 indicates a high voltage issue within the MAF sensor circuit of the Honda Accord from 2012 to 2017. Understanding the essential role of the MAF sensor and its connection to the PCM is crucial for accurate diagnostics. The common symptoms include an illuminated MIL, poor engine performance, and rough idling, all of which assist in identifying the root cause of the issue. The structured troubleshooting steps help isolate the problem efficiently, starting from visual inspections to voltage checks and PCM evaluations. By following these steps and performing regular preventive maintenance, vehicle owners can ensure optimal performance and reliability from their Honda Accord. The MAF sensor, positioned in the intake air passage of the engine, is responsible for measuring the amount of airflow entering the engine. This information is vital for the PCM, as it affects the air-fuel mixture necessary for combustion. The sensor uses a hot wire, which generates heat. As airflow cools this wire, the PCM measures the current needed to maintain that temperature. An upper limit of 4.89 volts has been established for this sensor's output. If the MAF output exceeds this threshold for more than 2 seconds, the PCM stores the P0103 error code and illuminates the MIL. This condition often arises when there is a malfunction with the MAF sensor itself or its wiring, making it essential to identify the underlying cause swiftly. There are several potential causes for the P0103 error code. One significant cause could be that the VGM, vehicle ground multi-line connected to the MAS sensor, is open, which would disrupt the sensor's readings. This open circuit prevents the sensor from properly communicating the airflow data to the PCM. Another possible cause is the failure of the MAF sensor itself due to wear or damage, which may lead to incorrect output readings. Lastly, a malfunction within the PCM's internal circuits could cause it to misinterpret the sensor data, producing a false high-voltage reading. A thorough examination of these components will help identify the exact cause of the issue. Drivers may notice several symptoms when encountering the P0103 error code. The most immediate indication is the illumination of the malfunction indicator light, MIL, on the dashboard. Additionally, the vehicle may exhibit poor engine performance, which could manifest as sluggish acceleration or difficulty maintaining speed. Increased fuel consumption can occur due to improper air-fuel mixture adjustments handled by the PCM. Lastly, rough idling or stalling may happen, particularly when coming to a stop, highlighting potential inconsistencies in air delivery to the engine. Observing these symptoms can provide critical clues for proper diagnosis and repair. The first troubleshooting step for diagnosing DTC P0103 involves a thorough visual inspection. It's important to check the MAF sensor itself as well as its associated wiring. Look for signs of any physical damage, such as cuts or frayed wires. Corrosion at the connector or any loose wiring can also lead to improper sensor readings. If any signs of damage are found, the affected components will need to be repaired or replaced. Also, ensure that all electrical connectors are securely attached and free from debris, allowing for optimal connectivity. This initial step can help eliminate obvious issues before delving deeper into diagnostics. The second step is to check the voltage output of the MAF sensor using a multimeter. Connect the multimeter leads to the MAF sensor signal wire and ground. While the engine is running, observe the sensor output. It should typically be below the established threshold of 4.89 volts. If the output remains high, this indicates a malfunction with the sensor itself. Document the voltage readings for comparison with manufacturer specifications and reference the diagnostic data for insights. This step is critical as it verifies the operational capabilities of the MAF sensor in real time, assisting in pinpointing issues within this circuit. In the third troubleshooting step, inspect the connections to the powertrain control module, PCM. Check for any corrosion or loose connections that may impede communication between the MAF sensor and the PCM. Poor connectivity may result in misinterpretation of sensor data, leading to the P0103 error code. Additionally, perform a functional test of the PCM itself. This may require specialized diagnostic equipment to ensure the internal circuits are operating as designed. If the PCM is found faulty, replacement may be necessary to regain proper vehicle function. This step underscores the importance of ensuring that all control modules are operating correctly. After completing repairs for the P0103 error code, it is vital to verify that the repairs have been successful. Start by using a scan tool to clear the DTC from the PCM. After clearing, run the vehicle through a diagnostic cycle to monitor for any returning codes. Pay close attention to engine performance during this period to ensure it operates smoothly. After a brief test drive, confirm that the malfunction indicator light, MIL, has turned off and no new error codes appear. This final verification ensures that the issues that led to the P0103 diagnosis have been effectively resolved, restoring vehicle performance and compliance. Preventive maintenance is crucial in avoiding DTC P0103 in the future. Regular cleaning of the MAF sensor helps prevent buildup that can lead to inaccurate readings. It is advisable to use specialized cleaners designed for MAF sensors to avoid damage. In addition to cleaning, routinely inspect the wiring harness and electrical connectors associated with the MAF sensor. Look for signs of wear, damage, or corrosion that could lead to connectivity issues. Finally, continuously monitor engine performance for any irregularities. Early detection can help avert more serious issues down the road. Consistent maintenance practices not only prolong the life of components, but also enhance overall vehicle functionality. Please like and subscribe to the channel. See you next time!